This is problem 8-140 from section 8.3.2. So far you have been able to extend the rules for real numbers to add, subtract, or multiply complex numbers. But what about dividing? Can you use what you know about real numbers to divide one complex number by another? In other words, if a problem looks like this, 3 plus 2i divided by negative 4 plus 7i, what needs to be done to get an answer in the form of a single complex number, a plus bi, so no longer a fraction? Natalio had an idea. He said, I'll bet we can use the conjugate. How? asked Ricky. Well, it's a fraction. Can't we multiply the numerator and denominator by the same number? Natalio replied. Natalio was not very clear in his explanation, showed Ricky what he meant they should do. If I multiply this original problem, 3 plus 2i divided by negative 4 plus 7i, times the conjugate of the denominator. The conjugate just basically means the opposite sign with the I term. So negative 4 stays negative 4, but I minus 7i. And I need to multiply by the same thing on the top and bottom. What I'm trying to do is get rid of the denominator. Okay? We saw previously in another lesson, if I multiplied the complex number times another complex number, that it gave you a real number, right? So that's what we saw on the top. So if I make the denominator be a real number, I can simplify it and really no longer have a fraction anymore. So if I multiply these times each other, let's just do the bottom first, because that's going to be probably the easier part. Oops. Okay, yes, we're going to solve it here, and then part B wants you to do something else. Alright, so negative 4 times negative 4 is positive 16. I'm doing the FOIL thing. If you want to do the rectangles, you can. So the inside terms would be negative 4 times positive 7i, so it would be negative 28i. And the outsides times each other would be positive 28i. So those would end up canceling out. So really we only have the last terms times each other, which gives me negative 49i squared. Right, and that's what should happen. I should end up getting a real number, no longer i's on the bottom. Now I'm going to multiply the top parts times each other. So I have negative 4 times 3 gives me negative 12. The insides would be negative 8i. Outsides would be negative 21i. And then the last numbers would be minus 14i squared. Ooh, that's close in there. Alright, so we can see that. I'm going to, let's see, we're going to move this down a little more. Alright, so if I simplify this, I can combine these together. So I'm just going to rewrite negative 12, that will stay the same. I'll have negative 29i. Right, and then my last thing, this negative 14i squared, I know I squared is worth negative 1, so that really becomes a positive 14. And divided by, I have 16, really, and positive 49. Same idea because I squared. So if I simplify this a little bit more, and I'm going to end up having 2 minus 29i divided by 65. Okay? So that would be my answer for this problem. When I divided two complex numbers, I still have a complex number. Okay? Using Natalio's ideas, you probably still came up with a fraction in part A. Yes, we do. But the denominator should be a whole number. Yes, it is. It's 65. To write a complex number such as c plus bi divided by m in the form of a plus bi, just use the distributive property to rewrite the results. Basically, we're just breaking down it into two fractions instead. So instead of saying all of that divided by 65, I'm going to say two different fractions. So 2 over 65 minus 29 divided by 65. And there was an I with that. Okay? That's all you're doing. So basically this should be our final answer whenever you're dividing complex numbers. Always make it into two little fractions with a whole number on the bottom instead of just one fraction. That's just kind of how they like to have it written.